Let me ask you something. Do you know what cumulative means? Don't stress it. I'll tell you. Cumulative is just a posh way of saying add up as you go along. And frequency is just a posh word for total. So, if you put them together, you get a very posh way of saying add the totals up as you go along. If you know how to add, then you can use that skill to construct graphs called cumulative frequency polygons, or simply Ogives. And that's what we're going to learn about in this video. Now, take a look at these marks gained by some students arranged in a continuous frequency distribution. How on earth do we represent this data with a cumulative frequency polygon? Well, let's first cover some basics regarding cumulative frequency. Cumulative means successive additions, like this 4 plus 8, 4 plus 8 plus 2, and then plus 6. Or simply this. As you can see, the last value of cumulative frequency will always be equal to the sum of frequencies. If you know addition, this lesson will be a piece of cake for you. Okay, stop thinking about cakes now. Okay, so cumulative frequency actually represents the number of observations occurring till a particular group. So, looking at our data, the first group tells us that 4 students got marks between 0 to 10. Till the second group, however, 4 observations of the first group along with 8 of the second group makes the cumulative frequency of 12, meaning that 12 students in total got marks less than 20. See what I'm trying to say? As you reach the third group, the cumulative frequency becomes 14 with 12 observations till the second group and 2 observations till the third group. This means that 14 students got marks less than 30. Similarly, the cumulative frequency of the last group becomes 20, which now shows the total number of observations till the upper limit of the last group. Also, since the total observations are less than the upper limit of a class, we can also call this a less than cumulative frequency distribution. It's all coming together now. Let's test our knowledge by constructing a cumulative frequency distribution for this data shown on the right here. You know the drill. First comes the class boundaries. Check. We leave this space blank here. Come on, you know why. In our previous video, I told you how you always have to add a 0 frequency interval before the first and after the last interval to get a closed polygon. But there's a tiny difference in this case here. We'll just add one interval in the beginning, but not the end one. We don't need it in the end. Our next step is to draw the cumulative frequency column with some old school successive additions. No big deal. Since cumulative frequency shows the total observations within a limit, we'll represent each cumulative frequency with its respective upper limit. We now have all the ingredients ready to make an ogive, so let's get cooking. On the left here, we're asked to draw an ogive for this given data. Let me take out my to-do list. A class boundary, column, an upper limit column for each boundary, and a cumulative frequency column along with a 0 frequency. Check, check, and check. Now, the cumulative frequency and its respective upper class limit is what our focus should be on. Let's write it like this. Much better. Time to plot. Using the same scale for both the axes, we'll plot the boundaries on the x-axis and their cumulative frequencies on the y-axis. You know what to do now. Simply plot each cumulative frequency against its corresponding upper limit of boundary with a point and then join all of them. We call this snake-looking graph a less than ogive. If we drop a vertical line from this final point to the x-axis showing the upper boundary value, we'll get a closed figure. This now becomes a less than cumulative frequency polygon. And that's a wrap. Now, go ahead and collect some data with your friends, then practice representing it using these graphs. As always, I'll see you all in the next video.